Today we'll have chapter 5. I post for you quiz 2 and exam 2 already posted. I put this one in the announcement in the iCollege, as well as I put this one here in your email. So please do those on time. And chemical reaction. Unfortunately, this chapter is already done in the lab before we started the lecture. So we're lecturing now about it, but we covered this one here, I think, last week. If you recall the chemical reaction experiment number 4, that was the case. So experiment 4, chemical reactions. And that chapter is the same thing, chemical reactions. Well, we'll start doing here. I will start here with the definition of a chemical reaction. Well, a chemical reaction here in general is always between compounds. We call them reactants. Those reactants can produce what? Can produce a new compounds. We call them what? Products. So we have reactants. Reactants, those are reacting together, correct? And then when they interact or react with each other, they can produce new compounds. Those new compounds called products. So that's what it really is. Those reactants are chemicals, correct? Chemicals react with each other, And as you can see, in general, we'll come back and look at the types of chemical reaction, but we did cover nuclear chemistry, correct? So nuclear reaction has to do with the nucleus, nothing outside the nucleus. However, here chemical reactions are always dealing with outside the nucleus. It's always dealing with VEs, valence electrons only, nothing with the nucleus, no nuclei. No nuclei are involved in the reaction here. So the reaction is exchange of valence electrons. So whenever those valence electrons interact with each other, one is giving, one is taking, or one is sharing those valence electrons, so we get a new compounds and new product. So this is about general thing about chemical reaction. Now we are interested more specific in a chemical equation. So everybody has this. Can I take it out? Everybody has this, correct? I think by now we are very professional, you know that, because we really went through this in the lab in very detail. So let's look at this. We have the chemical equation will be looking like this. What are the components of a chemical equation here? Well, component is the same thing, reactants. We have an arrow here. This arrow called separator. It does separate the reactants from the products. Okay, guys, so this is a chemical equation. So we have reactants, one side, the left side is always the left, and the right side here, this is the right, are separated. Those are compounds interacting with each other to produce new products, new compounds at the right side of the equation. So this is the equation. We have left of the equation, right of the equation, and the left or right between, the reactions and the products are separated by an arrow. Okay, that's in general uh, uh, the classification of a chemical equation. Now we'll get into some examples here, and we'll look how we visualize this type of settings. So suppose now I have sodium, correct? Sodium chloride. Sodium chloride will react with, this is aqueous. Aqueous means, the key again here, AQ means aqueous. Aqueous means soluble in H2O. Soluble in H2O. S, solid. G, gas. L, liquid. Also, the solid sometimes called precipitate. So, solid or sometimes called precipitate, abbreviated PPT. So we have here, let's take this equation out, write it here for you. We have sodium chloride, aqueous means soluble in H2O, and then blood plus lead 2 led to nitrate. Lead 2 means we have 2 here, the lead. This is again aqueous. This reaction here, they will swap. The lead will take over the chloride. We get lead, chloride, that's a solid, plus, and then you have sodium nitrate, NO3. So since we have two chlorine here, and here's one, so I put 2 here and 2 here. This is aqueous. So from this one here, we have recognized that those are the reactants. Those are the reactants. And those are the products. And this is our arrow. This is our arrow separator. Okay, guys, so this type here, you can see this is the setup of a chemical equation. Now, can I take this one out? Can I take this one out? No, not yet. Okay. Yeah, let's finish. This chapter is very, very tiny. It's not that big, so we will not finish it and go for chapter 6. Not today, of course. Not today, not today, not today. Just cool yourself down. Just cool yourself down, yeah. So, anyway, so can I take it out? Yeah. Has it? Take a snapshot of it. That's easier than to write after me. So, let's take this one out. Now we are looking at, before balancing chemical equation, I should have looked into what types of this. We have chemical equation, we have chemical reactions. We know the chemical equation is made from reactants at the left, product at the side, separated by an arrow called a separator. But we have to look into types of chemical reaction before we go balancing. It really helps. Before you balance chemical equation, you should be aware what type of reaction you are dealing in this chemical equation. So go for types of chemical reaction. Okay, so we have in the lab, as we did the first tab, we said the single replacement. And this replacement, sometimes in some textbook you will see displacement. They are synonym to each other. It does not really have any difference whether you're replacing or displacing. It's the same thing. And if you recall from the lab, I hope you are still remembering, because we have a midterm, correct, this week. So I hope you are still remembering. We have zinc. This is solid. We did with copper sulfate, blue solution. This is aqueous, soluble. Will give us zinc sulfate. This is aqueous. This is blue solution. This is colorless solution. And we got copper is kicked out, orphan. This is copper. So what's happened is in this one here, in this one we have zinc will take over the copper anion. So the copper sulfate, the copper is the cation, the sulfate is the anion. Zinc will take over the copper, kicking out copper by itself, orphan here. Okay, so this is single displacement. One single element will take over the other element's partner, and then kicking out this element away from its original partner. So copper, its partner is sulfate, the anion of it is sulfate. Now zinc will come in and kick out the copper out, orphan, and the zinc will take over the sulfate. So we are dealing from blue to colorless solution. So from blue to colorless solution. Okay, guys, that's the first type of reaction we did in the lab. So, any question? Can I take it out? Any question? Yeah, you can take a snapshot of it. It's easier. So, this reaction, we did this in the lab. And unfortunately, I wish that the lab would come, in the same wavelength with the lecture, but sometimes it's not. But anyway, so second type. Somebody will help me with the second type. Somebody still remember? If we have single, we will have what? Double. So if you have single, we have double. Double replacement or displacement. Okay, guys. So we had, if you recall, we have calcium, I think is chloride, aqueous, with sodium phosphate, aqueous, correct? And we're swapping those. Calcium will take the phosphate, PO4, 2, that's a solid, plus, remember, that's a solid here, plus sodium chloride, aqueous. So this is, we have here, this is a solid, this is a precipitate. So we can say this is BPT, precipitate, solid. PPT means precipitate. I'll not be able to write it, but that's precipitate. Precipitate. So, and all the rest are what? All the rest of the chemicals are what? All the rest of the chemicals is aqueous, so soluble in H2O, except this one here. This one will not be soluble. So now let's look at. I want to look into how we have double. So looks like calcium here will take over the phosphate. Correct? Calcium will take over the phosphate. And sodium here, will take over the chloride. So the sodium will take over the chloride. So they are swapping partners. So they are really swapping partners. The cation from the first one takes the second anion of the second compound, and the second cation takes the second, the first compound anion. So they are swapping. They're swapping each other. So, and we have what? We have a solid here is 4. That's double displacement. If we have single, we have always what? Double. So, number 3. Somebody is still remembering? Somebody is still remembering number 3. And we did this one type of reaction, and we did another type, if you recall, with the calcium carbonate. I told you the white chalk, the ceramic one. We did that. So if you recall, we added HCl plus the sodium carbonate, and this is solid. It was solid, and this is aqueous. So we had sodium chloride, aqueous, plus carbonic acid, aqueous. So if you look all in all, so you have 2 sodium and 2 here. So you can see you have the hydrogen here. Let's look at this. Hydrogen here. The hydrogen here will take over what? The hydrogen will take over the carbonate, and the sodium here, will take over the chloride. So they are swapping. That's the 2 reactions we did. The white porcelain, the chip, the boiling chips, or the calcium carbonate, sodium carbonate. Okay, sodium carbonate. So that's a double displacement. That's all those experiments we have carried out. Those until now, 3 of them in the lab. Let's take one. Can I take one out? Take it out. Remove the acid. Okay, let's take it out. We did we have 1 single double, and we have number 3. What types we have? Combustion. Okay. So combustion reaction is reaction with matter. Anytime I have a matter here with the pure oxygen, I get CO2 plus H2O. This is called here complete combustion. If I have a matter here plus oxygen, and I get CO2, and then I have a soot here, and then H2O. So this soot here or sometimes called charcoal particulate. So charcoal particulates called soot, and this will be incomplete or partial combustion. Correct. And we did this one here with cyclohexane. If you remember that, somebody remembers that. Okay, so we did cyclohexane C6H12 plus oxygen give us. We saw the cyclohexane was really burning itself. I mean, with the help of oxygen. So give us CO2 with H2O. And we did not see no soot here. So we did not see no soot. So it means this one will be what? This type of reaction will be what? A complete combustion, correct? This one is a complete combustion. Okay, guys. So let's look at example of incomplete. Okay, so I'm waiting. So everybody has it. Everybody has this. Everybody has this. Okay. Okay. Everybody has it. There, back there. Okay. Um, this is complete combustion what we did to cyclohexane. However, we did not have the chance to look to the incomplete. But I can remind you that in your chimney at home, if you have a chimney for burning wood, correct? If I have a piece of wood here in the chimney and then ignite this one here in presence of oxygen, I get CO2 plus soot plus H2O. And this soot, it will be part of the bricks of the chimney, part of the structure of the chimney itself. The bricks of the chimney will be black. You cannot get it out. It's very, very hard. So this is soot. So this is incomplete or partial combustion. This is because it has aromatics. Wood has aromatic compounds. And if I have just an example of this toluene looks like this one here, guys. This is called toluene. That's a liquid, correct? Insoluble in H2O, insoluble in H2O. So I burned this one here in oxygen. In the past, I did have access to toluene. This semester, unfortunately, I did not have access to toluene. I was burning this one here, and you get a lot of soot. CO2 came out, and a lot of soot here, and H2O. Too much came out of it. Even burning, the flame will burn out, and then a lot of dark smoke coming out. That's the soot. That is incomplete. So incomplete. So incomplete will give you this too much soot. Incomplete. So incomplete combustion. Okay, guys. This is number. We did single, double. Then we did single, double, and then we did combustion. We have two more. Can I take this one out? Everybody has it? Okay, everybody has it. That's good. So now we can go to two type of reaction. They are opposite to each other. They are what? Opposite to each other. Number 4, combination. We did that very nicely with the firework type of reaction. Took magnesium, solid. We burn it in pure oxygen gas, and we got this this white solid. So this is shiny gray, shiny gray metal, and here is white precipitate, white powder, and it came out a lot of UV light. But here it is. That's a combination, meaning what? I have more than 2 items here together. We have this one here, item 1. This is item 2. I get one single item, one single item here. You are combining those type of what? Combining those type of items or matters or compounds or chemicals together to get one single compound out of them. So this is what is called combination. Now, a combination has a synonym. Maybe we did not mention that in the lab, but at least you know that's a synonym of this. We can call this one here. Combination sometimes is referred to as synthesis, because you are making synthesis, making you are producing new compound. So the new compound is not by all means the same like the first those items coming from. So it's not similar to oxygen, it's not similar to magnesium, and that's what we mean combination reaction, also known as AKA as synthesis reaction. Why synthesis? Synthesis means you are producing a new compound, a new chemical. So, and that's magnesium oxide white powder has nothing, no physical or chemical properties of the original items or chemicals it came from. Not similar to oxygen, not similar to magnesium. Totally different. That's we call it what? A combination reaction. Now, if we have a combination, can we have the opposite of combination, decomposition? I'm combining here 2 or more or 3 or 4 items or chemicals. Push them together, I get one single compound. That's combining or synthesis, making a new compound. So can I take this one single one back to its original? Yes, and this called number 5, decomposition. So number 5 called decomposition reaction. Can I take this one out? Everybody has it? Everybody has it? Okay, everybody has it. Okay, let's take it out. So if I can combine, I can decompose. So number 5, the opposite of synthesis or combination is called decomposition. We did not have the chance to do this one here in the lab because of the fact decomposition needs higher temperature, above 1,000 degrees. We don't have an oven that's above 1,000 degrees. For the sake of, education, this one we have it in the research. If you have a research, then yes, because this is very dangerous. If somebody, if you get over 1,000, you will not be barbecued. You will be what? Turning yourself to sand. You know, some cremation, somebody is dead and then burning the whole body. Can you see a bones or something? No, you can't see bones. Just everything will be ashes, correct? Will be oxides. So the ash, the soil of the dead body is called, is really oxide, mixed oxides. Chemicals are mixed oxides. And then you can take it to a river or a pond and then or ocean and spread it all over the place. So decomposition. Decomposition is the opposite of combination or synthesis. So if I can combine, I can decompose. So here it is, as just an example. Calcium plus CO plus oxygen plus CO2. I can combine those 3 items in the air and I can produce calcium carbonate. Correct? So I can produce calcium carbonate. This is a combination here. So I can do that. So I'm combining calcium and oxygen. This one will give me calcium oxide. Correct? Calcium oxide react with CO2 to get then CO3. Combination or synthesis, correct? Now this is, I can get back out of this one here, and I'll take this one here, say, okay, let's take this one out. And by the way, those are solids, gas. So I can take calcium carbonate, put it above 1,000, 2,000 centigrade Celsius, as I said, you can calcium oxide plus CO2 gas. So this is gas, this is solid, white solid, and this is white solid as well. This is calcium carbonate. Those are the chips, the chalk, the white chalk. We had them in the lab. You put HCl on them, correct? Double displacement. But this time we have it at once here. If we heat it in a higher temperature, say over 2,000 degrees Celsius, you make out of it a white powder of calcium oxide and CO2. You see bubbling gas. This will be fuzzy gas or bubbling gas coming out. Okay, decomposition is the opposite of combination or synthesis. So now we'll come back to this type of reaction when we talk about redox reaction. That will come later on. But let's look at this one here now. We have the 5. Now we are ready to go to look at balancing chemical equation. Now we are ready. We know what we are dealing with, correct? We know the types. And then will come, that's my opinion. In the book, most of the textbook, they will go balancing, and then they'll give you the type of the reaction. My opinion is not a good idea. You can put all those types without balancing, and then come back and explain now how to balance those equations. So, can I take one out? Everybody has them? Everybody has them? Okay, good. Let's take them out. And with this here in mind, let me go and look at some of the worksheets. I mean, we do have here some of those here, I think. Some of those are here. You like those, or you like somebody from I pick your worksheets? Let us pick worksheet. Worksheet is more challenging than those in the whole thing. So, how I can search, how I can get worksheet for this balancing? What should I do? I need help. Come on, we know by now how to do it, correct? The topic first. What's my topic is? What's my topic? Balancing chemical equation, correct? Now, you can be fancy and add the plus sign, but Google will recognize it. But if you add this more affirmative, more, you are confirming that's to Google search engine. That's you have to add this other keyword to it. So, plus, what's the keyword? Worksheet, correct? Worksheet. Now, plus, if I'm lazy here, I want the answer ready for me. I'll say plus what? Answer key or answers. Okay, guys, but we don't need an answer. So let's take this one here out. So then click enter and see what will happen. Here we are, plenty of those. Now, if you are in psychology, A&P, biology, microbiology, and anything, decide the topic plus worksheets. And if you are not in a good mood, plus the answer. You don't want to work very hard. Plus the answers. All the answers are there as well. So those worksheets, they don't have answers, I hope. But sometimes, some very few, they come with answers. But when you say with answers, all of them will come with answers. So let's see this one here. I'm not sure. Let's not be biased. This is your choice. Look at those. 1, 2. Okay. 1, 2, 3, 4, 5, 6, 7. Even eBay sells. Can you see eBay? Take something not for money. No, you don't have to pay. The eBay means you have to pay. You have to pay. I mean, that's a business there. So 5, yeah. So which one you like? Which one? Not the eBay one. I'm not spending money on those. No. So which one? Go up. Okay, up. And here those images as well. By the way, all those images free too. Unless they charge, I'm not sure. But some website they charge, like eBay, like Amazon. Yeah, they charge. They sell those. So which one you like? Come on, guys. The first one? Okay. What's the name? De Anza College. Wow. DE, that's a, I speak German, you know that. German, let's start with DA. DE, that's always French. So this college named after a person which is he or she is a French. So D means like sir. The answer. But anyway, so that's a lot. They give you the answer. They are very nice, but we don't need an answer. So I put for you some there in iCollege, but you can be your own expert. Just type the topic, balancing chemical, and then with key, worksheet, and then key answer, and then you get all types. So, which one we would like to go through? Let me make this bigger here. So here it is. I'll go slowly here. Which one you think? Then I'll snip it out, and then we'll balance it, and then we'll determine the type. See, now we are determining we are balancing and determining what the type at the same time. So which one you like? Not the answers. We don't need the answer. Which one? Come on, guys. I know you will choose something cheap, something very easy, not very expensive. 13. Oh, that's not cheap. Okay, we'll see. Well, I'm saying that because they are selling those. That's a business. Maybe I'm thinking about the future, maybe selling those and making my own. So this one here, I'm snipping this one out, copying into our here Microsoft Word. Let me see here. Oh, paste it. So now, and then I will go for balancing combustion chemical reaction, which is very challenging. So let's pretend that we are not that professional. We are just beginners, correct? So as a beginner, we need a table to help us, correct? So we'll make a table here. Let's make a table here. We are beginners now, not very professional beginners. So we'll make a table. The table will be the first column called number of atoms or number of groups, because I'll show you we have sometimes groups come in parentheses, and then left, right, and then status. So we have, okay, so let's define what we are dealing with. So the left of the equation here, that's the reactants, correct? That's my left. L. Those are my reactants. This is my separator. That's my arrow. Separate, correct? And this is my right, correct? And this is capital R, and this is my product. This one just one, but sometimes you have more than one same product, or yeah, reactant product. So how many atoms we have, type of atoms we have? We have aluminum here, and we have sulfur. Do we have another one? No, we have those two. So in the left, how many aluminum we have? Aluminum is 1. In the right, how many? 2. Status, not balanced. X means not balanced. Sulfur is left is 8, and 3 is not balanced. So no, the good thing is no rules. That's the good thing is if you have something without no rules, it's very nice, correct? So you don't have to memorize. No memorization, no rules. So what says? Always what? Trial and error. So keep trying until you get all number of atoms at the left equal number of atoms at the right, all number of the groups at the left equal number of the groups at the right. So my intuition will tell me what? Let me just change the color here. Let's take green to keep you awake. It's not Monday today. So what should I do if I'm having this 3 and 8 and 2 and 1? What do you think? Which one I have to start with? One? Which one? What should I do? Those are the more coefficients or the more moles will come. We have to put something in front of them to balance it. So, put 2 in front what? Aluminum, okay. Now you get aluminum straightened up. However, aluminum is now 2. Aluminum is balanced. How about sulfur? 3. Now here it is. Anytime, there are rules? No, there are no rules. Anytime you have, just listen. I thought that's very cheap. It turns out to be very expensive. Anytime I have a conflict between odd, left odd, right odd, or left, right odd, or even I have a conflict in odd, or even, then I have a problem. So here I have an even number, 8. That's an even number. Here I have 3. That's an odd number, correct? So this is odd number. When it's 3, correct? That's an even number, correct? 8. Now, my intuition, there are no rules. So I have to get through what? Fraction. Through what? Fraction. So whenever you have this situation here, okay, even an odd thing, you have to go through fraction. Now, this is no rules, but this comes from experience through fraction. So how about if I say I'm going through fraction, correct? So let's do here. I'll just put this one here. Can I take this one now? I'll put this one right here. So here is 3, and here is 8. I put the 8 at the bottom here. Why? Because I want to cancel the 8 with the 8. Put the 3 up front, correct? And the 1 is here. The one's understood, not written, is 1. So I have 3 over 8. But nature will never support any fractional atoms or molecules. There is no half a human, there is no a quarter of a human there, because we are made of atoms too. We cannot break our atoms in halves or in quarters or whatever, in fraction. You cannot. And nature will tell you that's not possible. So what should I do? I did 3 over 8 to get the 8, and the 8 cancels out, correct? That's good start. So what's next? Come on, guys, don't let me down. What's next? Since we have the 8 here, that bothers the whole thing, bothers even the nature itself, because you don't have fraction of atoms or molecules, correct? So I will say, take the whole equation here, multiply it by what? By 8. Then I have the 8 with the 8 cancels up front. Everybody's following? That will be 8 multiplied by 2. Now I have 16 aluminum plus 8 multiplied by 3 over 8. 8 with 8 cancels out. 8 with the 8 with the 8 cancels out. So it will be what? 3s8, correct? And will give us 2. 1 multiplied by 8, 8Al2S3. Correct, guys? Now, see if that's correct. Do we have 16 aluminum in the left? 16 aluminum in the left. Do we have 16 in the right? Yes. Do we have 3 multiplied by 8, 24 sulfur atoms in the left? And in the right, this is 3. Correct? So let me write it here again. 16 Al plus 3, 6, 8 goes to 8 Al2S8. Okay, guys, can you see it? So now, next, what we have to know? We have to know the mole ratio or the coefficient ratio. So those are numbers in front of each compound or chemicals of atom. So in front of aluminum, we have what? 16. So 16. And then 2. 16, 2. This is a ratio. 2, what here? 3. And what here? 8, correct? So I have here, this called here, mole ratio, or sometimes called, can't write it here, so coefficient ratio. So 16 to 3 to 8. That was a very good one. I thought, and underestimate it will be very cheap. It's very easy. It's easy, but you have to get the fraction out. So we'll look into that in the combustion. So everybody has this? Everybody has this? Okay, let's take it and then let's look at another one. So which one you like? We'll do another one and then I'll go for combustion. Another one and another combustion. How about 19? Which you like, 19 or 17? 19? What's that? 21? No, I like 21. How about that? And then we'll go for 19. Maybe it turns to be not very expensive, so let's do 21. Okay, so let's look at that. Let's look at that. So as I said, those are very challenging and those very good. They might be in the ACS exam. They bring you some challenging one like this. So still beginners, correct? Or we are okay? Are we beginners or we need a table or not table? Table or not table? Table, okay. So here it is. This is my left. This is my right. And we'll do here number of atoms, number of groups. Okay, this is my left. This is my right. And this is examine the status of it's balanced or not balanced. So we have how many? It looks like we have carbon, hydrogen, and oxygen. Okay, so let's look at the left. How many carbons we have? Let's count them. 1, 2, 3, 4. 4 carbons. How many there in the right? Only one. This one here. Okay, how many hydrogens in the left? 3 plus 2, 5. 5 plus 2, 7. 7 plus 3, how much? 10. 10 hydrogen. I count them singly, is correct? So how many in the left? How many in the right? 2. So this is not balanced, this is not balanced. So let's take oxygen in the left is 2. Here it is. Oxygen in the right, how many? 3. Somebody said 3. Correct or not correct? Correct. This is 2 here. And this is 1. So it will be 3. Again, it's not balanced. So again, no rules, no rules. So what your tuition will tell you to do? Well, there are no rules. I will say, let's start. I mean, we can start with hydrogen or carbon. But my intuition through the years said, whenever you have combustion reaction, leave oxygen at the end. Don't touch it at the beginning. So leave it to the end. So leave oxygen till the end of the equation, till end. Okay. So that's not a rule. That's just from exposing myself through the years, over 30 something years. dealing with those balancing. So you can say that's the best is to keep oxygen out of the picture for now until I get all those balance all the atoms. Then I'll come back to oxygen because it might have fraction. Then I have to do what I have to go through the fraction itself. So let's do carbon. So how much I have to put carbon? Here's 4. I have to put what here? 4, correct? Straightforward. So now the right is 4. This is balance. Okay. So how about hydrogen? It's 5. Hydrogen is how much here? So how much I put here? 5. Hydrogen is 10 at the left. 5 multiplied by 2, 10. Why I put 5 in front? Because in the left hydrogen is 10. And here is 2. This is 10. This is 2. So now this is 2 is 10. So this is balanced. So 4 and 5 balanced carbon, and the 4 balanced carbon and 5 balanced hydrogen. Now by doing this, I have disturbed the oxygen, correct? So now 4 multiplied by 2 is no longer 2, is 8, correct? And 5 multiplied by 1, understood, not written, is 5. So how many is this? Oxygen, 8 plus 5 makes 13. That's oxygen. Now, see here. Oops, sorry. Now, this one here, oxygen here. Look at this oxygen. Well, I have oxygen is what? 2, and here is 13, correct? So what should I do here? So, well, I have same issue. This is an even number. Even number. That's 2 here. 2. Even number of 2. And here is odd number, which is 13. So what should I do? I have to go what? Through fraction. And this, whatever is the highest number here, the highest number will be always at the top because I want to get rid of whatever is whatever it's the subscript of the oxygen. Oxygen is 2. Always 2 here will come at the bottom. So let's do here. Let's take this one out so we can't see much better. So I put here the 2 here. Why I put 2 here? Whatever the number here. Suppose I have ozone 3, O3. So I have to put at the bottom what? 3. So I can cancel. I make the oxygen is 1. Then I put the number 13. That will balance the whole thing. 13 over 2. So this number here will be always at the top. Always this, the bigger one number, always at top. And the oxygen number here, whether you have ozone or O3 or nitrogen N2, the 2, whatever the number here has to be at the bottom. So you can You can cancel them easily out. So I can cancel them easily out. So the two cancels out. So, but nature does not support any fractional element or molecule or anything fractional. Nature does not support it because it's not staying. It is not. There is no fractional atom or molecule. So, what should I do? What should I do? I have to get rid of what? Of the 2 there, correct? So I have to get rid of this. The 13, okay, in the top, but the bottom is 2. So I have to take what? The whole equation multiplied by 2, correct? So I have to multiply. So this is not balanced. So this is not balanced. So 2. So we'll be here. Let's put this one here. Can I take this one here out a little bit, or no? Just let me. I'll make another maneuver here. I put this one here somewhere. I hope it will work. Well, it did not work. So, but anyway, so okay, let me take maybe enter box. Hold on, hold on, hold on. I'll show you some technique here. Anytime you have problems typing, what should I do? Insert, and then I say insert text box. That will make me happy with this, and then I can move it anywhere I want. Okay? No, I just not want to go further. So here it is. Okay, guys. So taking all the stuff out, and I'm pasting the whole thing. Can you see it now, guys? Can you see the equation now? I can make it even a font maybe bigger. Yeah, anytime you have issue formatting, it went out. I do not take. Okay, guys, here it is. So we have 2 multiplied by the 2 multiplied by the whatever the carbon, correct? So I have here 2 multiplied by the whole thing. So let's put here 2 here, correct? And then oxygen is what? 13. The two cancels out. 2 multiplied by 4 will be 8. And 2 multiplied by 5 H2O will be 10. So now, tell me here if this is correct or not. Tell me if this is correct or not. Carbon is 4. 4 multiplied by 2, carbon. So carbon is 4 here. 4 multiplied 8. And here is 8. So carbon is good. Carbon is good. Hydrogen is 10. Hydrogen here is 10. 10 multiplied by 2, 20. And here we have hydrogen is 10 multiplied by 2, 20. That's balance. Oxygen is 26. Oxygen is here 26. Oxygen is here 16. And here's 10. 10 multiplied by 1, understood, not extent 10. That's 10 here. So this is 26. So this is balanced. Oxygen is balanced. So the ratio will be, what will ratio will be? Somebody will tell me what's the ratio? 2 to 13 to 8 to 10. This is the mole ratio, or called coefficient ratio. Okay, guys, let's do 19 and then we are done with this. Okay, guys, so everybody has it? Okay, so let's take this one out. Everybody has it? Okay, so let's take this one out. Take this one out as well. Okay, let's take, you said 19. 19 is the same thing. It looks like, I don't know, but we'll see. So now I will assume that we are professional by now, I hope. Put great hope in this. So we are professional, meaning what? We don't need what? Tables. We'll do it without tables, correct? So it's ours. So without tables. So now we are professional, I hope. Everybody agrees? No? We'll try it, we'll try. No rules, no nothing. So carbon is what? 10. And here carbon is what? 1. So I put what? 10 up front. Okay, guys? Hydrogen is 22. Hydrogen is 2. I put what? 11. Okay, here is 1. Understood, not written. I don't write, but understood, not written. Now the problem with oxygen, here is an even number, 2 at the left. And here I have 10 multiplied by 2, this is 20. That's all of it about oxygen now. 20 here. 20. And plus, here 11, understood, not written, is 1 plus 11. So how much is this one here? 31. So oxygen is 31. This is the right side. But here oxygen is, the left side is what? Is 2. So what should I do? The top one, the larger one will go where? The top or the bottom? Where? At the top. So this is 31. And this is the 2 here, because the 2 here, I put the 2 here so to eliminate. Now I have oxygen is 31 at the left, 31 at the right side, correct? Now, my intuition will tell me that's not correct, because nature does not, support any fractional elements or molecules or compounds, correct? So what should I do? Since it's 2 here, that's occurs that fraction, not the 31. So I take the whole equation, multiply it by 2. So I have 2 multiply, then maybe here. It's not 1, 2. Okay. I have to go and insert the same thing we did. Insert text. And so the text is here. And okay, guys, so now by adding the 2 here, 2 multiplied by 1 is 2. 2 multiplied by 31 over 2, 2 cancels out. This is 31. 2 multiplied by 10 is 20. 2 multiplied by 11 is 22. Now check it out. Let's check this one out and see if things are balanced. So let's check this one out. Carbon, how many we have carbon? 2 multiplied by 10, carbon is 20 at the left. Carbon is how many here? That's understood, 1. Carbon is how much? 20. That's good. Carbon is good. So hydrogen is how many? 22 multiplied by 2 is 44. And hydrogen 22 multiplied by 2, hydrogen is 44. That's good. Okay. I have oxygen here is how much? 62. 2 multiplied by 31, 62. And here, 20 multiplied by 2, this is 40. 20 multiplied 40 plus 22, this understood, not written, is 1. Plus 22. How much is this? 62. Now, looking at both left and right, it looks like we are, carbon is 20, 20 balance. Hydrogen 44, hydrogen is 44, and oxygen 62, and oxygen 62. This is the equation is now what is balanced. And the mole coefficient is 2. This one is 2. To what? 2. 31. To what? To 20. Okay, guys. To 22. So let me take this one here out. To what? 22. So this is your mole ratio, or called coefficient ratio. So, everybody here? Now, one more thing, we did the fraction, we did the combustion. One more thing about the groups. We did not see a group here, correct? Parentheses. Let's look at one of those and look at the parentheses and see how we can solve it. Can I take this one here out? Everybody has it? Everybody has it? Yes, no? Everybody has it? Okay, let's take this one here out. And let's take all this out here. Let me see here. Take all this one here out. Okay, guys. We'll take one that has yes, number 25. Number 25 is very obvious. 25 for groups. Very obvious for what? For groups. Or again, 28, the same thing, correct? The same thing with 28. 31, which you like? 31, 28, and 25. Let's select one. That will cover something called the groups, because we are, and 20, the 20 is the same thing, but 31, okay, 31. Let's take 31 here. Okay, so edit, copy, and then we'll paste it into this, paste. So, is this? No, it came out previous one. Why? Oh, that's the other window. Okay, copy. Okay, guys, let's do this one here, paste. Okay, guys, here we are dealing with, just to show you this I might show you better with the table. So, although we are very professional now, but we are doing it with the table. So, let's do it with the table because I want to show you the groups. Until now, we did atoms. We did not do any groups, correct? So, this is my left again. This is left. This is my right. And then I have number of atoms or number of the groups. Here we are dealing with what? Groups. This is my left. This is my right. This is my status. Now, whenever I have one side parentheses, the other one is not, it means I have groups. Anytime I have parentheses here and parentheses here, those are groups with parentheses or brackets. Anytime I have brackets or parentheses, I have groups, which are then this is OH group, and then I have phosphate PO4 group. So it is. So I have two groups. Okay. I have two groups, and I have the elements is here. I have two elements here, calcium, and I have, beside calcium, I have what? I have hydrogen, correct? Here's calcium, and here is hydrogen, without the group, hydrogen. So, now I recognize that I have groups. So let's look at this. OH group in the left, how many? How many groups I have? I'm not taking those apart. Do not attempt taking those apart. It will take you forever to balance, and you get an error. But if you take them as a group, and you have to recognize that's H2O every time. H2O is nothing less than HOH, one parenthesis here. HOH, that's H2O. It has what? It has one, this is a group, OH, group. And that's really true. H2O is HOH. H plus or H minus with the charges. But anyway, so I have the hydroxide is 2 here. At the left hydroxide, remember this HOH is understood nitrogen is 1. So this one is not balanced. Correct? The phosphate is here, right, is 2. But the phosphate is, I don't recognize it here. There's no parentheses. I will make a virtual parentheses here, like this. That's a virtual one. Virtual bracket or parentheses. So I will say, okay, brackets or parentheses, I can make them. Why? Because it come here as a group in parentheses, correct? But here it's not. I will make another parentheses. It's not wrong. It's not wrong. So in the left is understood nitrogen is 1. 1 and 2. This is not balanced. Calcium is 1 at the left. Calcium 3 at the right. Correct? Do we have them all? Do we have them all? Then we have 3 of hydrogen at the left. And how many? So the OH, we recognize the OH as here, already here, this. But here is H1. So not balanced, not balanced. All of those are not balanced. So now you tell me how to balance them. I go by the groups. I said to myself, or you can with the calcium. I mean, it's up to us, but it's better to start with the groups. So I have the phosphate here is 2. The phosphate is 1. So how about putting here? Cool yourself down. We have 2 minutes, guys. Cool yourself down. Cool yourself down. I put 2 here, correct? Then the phosphate is 2. That will take this one here, correct? That will take care of the phosphate. I have then the calcium is 3 here. That I put 3 here. See what will happen. Calcium is 3 at the left, 3 at the right. That will take care of calcium. Now the OH is 3 multiplied by 2, 6. How about putting here, correct? 6 in front of it. I have 6 group OH, correct? So then OH is in the left 6 and in the right is 6, correct? How about the hydrogen? Hydrogen 2 multiplied by 2 is 6. And the hydrogen 6 multiplied by 1 is 6. So what's the mole ratio here, guys? This is one understood, not written. Mole ratio is, here, let me write it, 2 to 3 to 1 to 6. Perfect. Okay, guys? So then we'll go the mole rate, the mole Avogadro's calculation next time. Okay, guys, thank you.